All right, we're looking at recoil here. So again, this is a collision where momentum is conserved. So we have to first look and see, is there no net external forces on our system? And so the example we're going to look at here is a student on roller skates. They have a mass of 60 kilograms. They're holding on to a 5-kilogram ball, and they're going to throw that ball. And so no friction with those roller skates. And in the x direction, there's no other forces other than the forces between them. That's okay. We just can't have a net external force on them. Okay. And in these situations, they start together and end apart. So in our case, the student is holding onto the ball at the start, and at the end, the two objects are separated. In these situations, we see an energy gain, typically because there is work done between the two objects, whether it's, a student throwing a ball or chemical energy being released in maybe firework, something like that. Okay. So in our situation, because this is a recoil, because they start together, these two initial velocities are going to be the same. So what we'll do is we'll say m1 plus m2 times a common initial velocity is equal to m1 v1 prime plus m2 v2 prime. In our case, the initial velocity of the student is 0. So holding the ball, so this whole side cancels off for us in our problem. We are going to go ahead and solve for the velocity of the student. So if the student throws the ball at 3 meters per second, how fast are they going to recoil back the other direction? So we're going to go ahead and solve for v1 prime. So I'm going to move m2 over to the other side. So I have negative m2 v2 prime equals m1 v1 prime. Divide the m1 over, plug in my numbers. So I have negative 5 times 3, all divided by the mass, which was 60, is equal to v1 prime. I see I got a negative sign here, so my answer comes out to negative 0.25 meters per second. This negative is just telling me the direction, and does that make sense? Yes, my student is now moving in the negative direction. Okay. We can also do the change in kinetic energy for this one. The final kinetic energy minus the initial kinetic energy. There is no initial kinetic energy because they start at rest, so I don't have to do that part of my equation here. So the final kinetic energy is 1/2 60 times how fast the student is going, so 0.25 squared. I can put the negative in there, but it's going to go away because of the square, plus the kinetic energy of the ball, 1/2 times 5 times 3 squared, minus the initial kinetic energy, but there is none because the boy and the ball are not moving initially. Now that doesn't mean that the boy couldn't or student couldn't be rolling on the roller skates and then throw the ball, but in our case it didn't have that. And so our change in kinetic energy was 24 joules, and the fact that it's positive means we've gained energy. Work has been done by that student pushing the ball. Okay. That's recoil.